My name is Mike Willard, and welcome to my course, Python Functions and Libraries for Cybersecurity. I am an information security manager who grew up coding in order to automate a lot of the tasks and work I did not have time for. Python is a very powerful tool with massive public support that gives you an insight into all the aspects of your networks, endpoints, and cloud applications. In this course, we're going to cover some of the modules, methods, libraries, and functions that are important to know and understand so you can build your tools to defend, discover, and eliminate malware, to pen test your network, or encrypt your sensitive data. Some of the major topics we will cover include: why is Python important to cybersecurity? How is Python used in different cybersecurity positions? Core functions that are important to understand, and third-party packages out there that support the cybersecurity field. By the end of this course, we'll have talked through some of the best libraries and functions that will get you started so you can protect the top areas of your business in our networks, processes, operating systems, malware, web applications, and cryptography. Before beginning this course, you should be familiar with introductory Python coding, as well as some of the coding standards and basics of writing Python scripts. I hope you'll join me in this journey to learn about how big of an asset Python can be in your cybersecurity career with Python Functions and Libraries for Cybersecurity course here at Pluralsight. Hello everyone, my name is Mike Willard, and welcome to my new course looking at an introduction to Python Functions and Libraries for Cybersecurity. We're going to explore some of the more common libraries, packages, functions, and methods of Python that cybersecurity personnel can utilize to build tools, monitor networks, respond to incidents, and pen test the environment they work within. There are currently over 600,000 unfilled cybersecurity positions in the United States alone. Teams are understaffed in a department that can't afford to miss. Being able to supplement skills with tools and automation is almost a necessity. The teams cannot be everywhere, look at everything, and do it around the clock. So why Python? Well, Python is considered to be a friendly language for beginners, as there is a focus on readability, making it easier to understand and use. Its syntax has similarities with the English language, making it easy for novice programmers to leap into the world of development. This is important because most professionals in security probably did not start out as developer. We're simply looking for an easy and powerful way to automate jobs through scripts. And because we don't work in a bubble, our scripts must touch the full stack: Windows, Linux, Macs, Unix, or if your organization is building Android and iOS apps, or builds with .NET, PHP, Java, or any of the other dozens of languages out there. These all present their own challenges, but the beautiful thing is Python is multi-platform and works across them all. And, in fact, comes pre-installed on Macs and Linux, or is a simple install in Windows, which we'll demonstrate here later. We're only as effective as the tools at our disposal. Python, being open source, solves a few very important problems. It is easy and free to implement. You don't need to spend thousands of dollars to solve basic problems. I mean, security is complicated enough. We are an inherent disadvantage to the attackers. We have to help each other out so we're not constantly trying to reinvent the wheel. If there is a tool that gets you close to a solution, but because of a nuance in the business requires a tweak in the code, Python, being the open and easy to understand language that it is, can easily take an off-the-shelf tool and fork it, allowing your company to customize it to your problem. Now, to build off that, thinking you have to write everything from scratch is the hardest part of coding. For people who do not code for a living every day, who do not live the software engineering life, writing even just scripts seems like a daunting task. Luckily, Python has a standard library with hundreds of functions. And in true open source fashion, there are hundreds of packages with thousands of more functions that allow you to quickly solve many problems very quickly. In this course, we're going to cover some functions I see as being important to the information security field. I will also provide as attachments to this course a list of other packages, tools, and methods we are not able to get to, but you may find useful to research on your own. So that is my take on why Python is important to this field. In the next clip, we're going to talk through some of the examples of how it is useful. Python is extensively used in the information security industry, whether in exploit development, networking, debugging, encryption, decryption, reverse engineering, fuzzing, web, forensics, malware analysis, you name the function, you can probably find some use of Python for it. Talking through some of the more common job titles, security analysts find themselves having to process data quite regularly. So many nightmares about logs, sometimes you just want to gather them all up and throw them in the air and scream. There has to be a better way to get to the root. Yes, we have solved a lot of this with SIMs and log aggregators, but what if you don't have the space to import and digest all the logs you want? Sometimes you may not have the budget or find value in regularly processing test environment servers in your SIM, but all of a sudden you're getting port scans coming from the box. Python allows you to open a file, process the information in that log or file, and produce a report of the content in that file. Another function of an analyst is to monitor environments and audit the new installments against your hardening policies. When you are spinning up new cloud infrastructure or open tunnels between cloud services, it can become cumbersome to manually work a compliance checklist. Mistakes are easy to make. You don't want the security of your org compromised because an analyst simply missed checking a specific configuration that was set wrong. Another use of Python could be to pull up a script, point it at the infrastructure in question, and know all the checks are taken care of. What I'm really getting at here with these examples is automation. Your basic and repeatable tasks that bear down heavy on getting it right in order to maintain the proper security posture. These tasks, with the help of Python, can be scheduled and automated to do the heavy lifting for you. Shifting focus to the individual or team responsible for the security awareness training in your business, Python may be used by this group to help build tools to assist in demonstrating how an attack is executed. Maybe you set up a simulation to show how a password cracking attack works to gain initial access into a target environment. Once a foothold is established, the Python script can then traverse the system, collecting information about the box, including accessing sensitive data. We will then set up a command and control channel between a target and an assumed attacker's infrastructure to exfiltrate the data out and send other commands back to further the attack. In response to such an attack, incident responders can use Python to understand what is going on inside the box or network compromised. There are libraries and tools to help execute a memory dump, or packages like Scapy can be used to capture packets on a network to understand where the compromise has spread. This leads to the forensics being conducted to understand the attack. You have the obvious malware analysis or binary analysis, but Python is just as good as important functions like digging into records to preserve file and folder metadata. A chain of custody and protection against changes in the files can be accomplished with crypto libraries that generate hashes of the content. And to further put the exclamation point on this, here are a few more uses you will see throughout the information security community. There are many uses, and every job can take advantage of the multitude of packages and functions offered in this tool. In the last clip for this module, let's talk about how libraries and packages effectively work and walk through some demos setting your environment up to follow along in this course. Packages are an important element of software development. As I mentioned before, this keeps us from reinventing the wheel. We don't want to waste time on code that has already been written and problems already solved. Packages allow us to parse these log files, network communication, encryption. Oh man, just think if every time we wanted to hash a file, we would have to roll our own encryption. Now let's walk through a quick demo demonstrating how to set up the environment for this course, and pulling down some of your first packages to be imported into Python. All right, in this demo, we're going to walk through a few steps here. The first and foremost is where to go and find Python, how to install it. It's probably an important piece for a Python course. I am on a Windows desktop, so I'm going to walk through it from that perspective. I'm also going to use a tool called Visual Studio Code. It is a free Microsoft download. I'm going to walk through how to set that up, get it set up to work with Python. From there, we're going to talk through where do we get these packages, libraries that we're going to be talking about in this course, and then finally how to install them. So I am on the python.org website right now. You'll see a downloads button here right at the top. There is one item I do want to mention. So the yellow download button will give you the latest version. If you do click on this downloads button, you can then go down to releases, and that will allow you to go through all the different releases. So maybe I don't want to install the latest version. Maybe I need an earlier version. Maybe I'm working on something for a specific project that it requires an earlier version. So this will allow me to grab any version that I want within reason, within supported Python download. From there, once I download the package, I'll kick it off. So 2 items to note on this install package for Python. At the very bottom, if you have this checkbox to add Python 3.10 to the path, it's very important that you check that. You don't necessarily have to check it, but it makes everything within Python so much easier if it's there. So I would definitely look to check that. From there, I'm going to just use the Install Now button to get this installed fast. But there is a customized installation where you can check and uncheck various bits. One thing you're going to want to leave in there, especially for this course, if you're going to follow along, is the pip. But everything else is at your discretion if you want to install it or not. So I'm going to get this started, and while that's going, I'm going to jump back into my browser, and I'm going to head over to Visual Studio Code. So Visual Studio Code is a nice free tool Microsoft puts out there. To download the Visual Studio, you can use the blue button and just download the latest stable version, which is just the user installer version. If you were to go over to the downloads page, one thing to note on here is there is 2 different versions. You have the user installer version and you have the system installer version. The biggest difference there is system installer puts code on the puts code on the desktop for everybody to use, all the different users of the system. The user installer is just your personal user, so the person who is currently logged into the system. I highly recommend, especially if you're not sharing your desktop with anybody else, your laptop, to use the user installer. It does not require admin credentials. It does not require, when you do your updates, to have any type of special privileges. It puts everything into your local app data path. So I highly suggest, if you're not needing to have this spread out across multiple users on this desktop, that you simply just use the user installer and install it that way. So I'm going to download that, and now I should be able to go back, and my Python was ready. So Python, as you see there, does have a disabled path length limit. Not necessarily that you have to do that, but it might not be a bad option for you, just something you need to figure out and determine if you want to do that for yourself. So I'm going to close that, and then going to go over to my code install that I just downloaded. I'm going to accept that, get that pushed through. Nothing really dramatic with the code. We're going to wait for this one to finish. This only takes a few seconds. And at the end of it, I'll be able to jump into the Visual Studio Code program, and I'll walk you through some additional steps we need there. So now that I've got it started, I like my dark, and I'm going to just mark this done. Let's get right in here. So one of the first things we need to do in order to get Visual Studio Code to work with Python is we got to come over to this extensions icon here. Building block looking icon. I'm going to open that up. At the search at the top, I'm going to look for the word Python, and I want to make sure that the Python I'm selecting is the one that is published by Microsoft. I'm going to hit the install button next to that, and that's going to kick off an installation of Python. And one of the other things you're going to notice when I look for the PyLance, this is kind of like an extension of Python within the Visual Studio Code. So it's an extension of the extension. That is also kicking off. And as you can see there, some of the stuff that it adds. But when it's done, it'll bring you back to your main page. You can close this extension out. I do have the ability to look at one of my projects that I'm setting up for this course. So let's open that up here, right on the desktop. I have my Pluralsight. I'm going to select that folder. So I'm going to be able to see everything within that folder that I have ready to go. And one of the tools that we're going to open up is this psutil.py. one of the things I want to point out is, we went through the whole process of setting up a Python extension in here. And in the bottom right, it shows you that, hey, it's using Python. And not only that, it's using Python 3.10.2. If I use a shortcut key of Control, Shift, and P, it's going to open up a little search box here. And I'm going to type in Python select interpreter. So once I do the select interpreter, you're going to see all the different interpreters that are available to me for coding in Python. Right after this demo, we're going to get into a few other interpreters that are out there. I did make mention that, when you're going through the Python download, that you can select multiple different versions. So every different version that you install, you can choose which ones you want to use for this project. So that's a nice way of jumping between the different versions. But once you select the interpreter you're going to use, I have some code here. So we can either open up a command prompt and start to go through and play with this script that I have open, or you have a little play button in the top right corner that opens up a terminal window. So after I hit the play button, it's going to go through a few steps and whoops, oh, wait a second, we don't have the psutil library installed. So what we're going to need to do is open up our terminal window, command prompt window. And because we installed Python with the pip, I do have the pip program ready for me. But first I need to make sure that I have the latest version. So the first time through, you just want to make sure that you have the latest version of pip on here. So I'm going to do pip install -- upgrade and then pip. So what I'm doing here is I'm saying I want to install using pip an upgraded version of pip. And it's going to go through and it's going to get the latest version of my pip installed on here. And when it's done, it's going to come back to the prompt. So this gives me the latest version of pip. So now I can turn around and say I want to install that psutil library. So one of the things I want to show you real fast here, if we go back to the browser, you have this py.pi.org site that gives you all the different libraries. It's basically a repository of all the different libraries and packages and modules and everything that's available to you in Python. I'm looking at the pip page right now, but if we go back to the home page, I'm able to see everything that's available to me. I can do a search for any of our packages. I am going to go back into the pip because there's one thing I want to show you in there. So once I'm back in here, on the left-hand side, you have documentation, you have download files if you want to fork one of these packages. You can also install it different ways, but pip is the way that I'm going to really show you and play with today. On the left-hand side here, you have the documentation button. When you click on that, it's going to take you over to this packaging.python.org site. We're going to want to look at on here a tutorial for installing the packages. And about halfway down on that page, you're going to see a section here where it starts to get into all the different ways you can use the pip to install. One of the things I want to point out here is you don't always have to install the latest version of a library package. You can simply insert the name of the package in there and it will install it. But you could also do an equal sign and say I want to install a specific version of a package. Or I want to install a compatible version, a version that's older, or any of these different options that you see here. But one of the things that really is important for you to understand is you have this information available to you. This package indexer site is super important. Gives you all the documentation you may need, how to download it, where to go for additional information. But once we jump back to our command prompt, you'll see I'm just simply doing a pip install of the psutil. And now that's finished. I can jump back into my Visual Studio Code program and I can run it and I can see that it went through and completed successfully. So I'm able to kick off my jobs. I could see it within this terminal page here, or I can open it up in command prompt and we go through it. But for now, that's all we really wanted to get into at this early stage. What we just walked through was the default implementation of Python, or sometimes referred to as CPython, not to be confused with Cython, which we will get into later. Your situation and the use case may call for other implementations though. Let's talk about a few of these. Cython allows you to write Python code but compiles your files into Java bytecode. This allows your code to run on the JVM. Multi-platform for the win here. Jython has a few quirks that tie it closer to Java versus Python, such as implementing garbage collection. IronPython, similar to Jython, allows you to code in Python, but compiles your code and prepares it to run on the Microsoft CLR, which includes C# and .NET. The last two on my list here are slightly different variations of that. PyPy, another variation of CPython, but utilizes a concept called just-in-time compilation, which compiles the code when executing. This in turn speeds up the processing at runtime. Finally, Cython, similar to Jython, but allows you to compile programs in C rather than Java, giving you the ability to take advantage of both the C and Python languages, but having the comfort of writing everything in the Python language. Each implementation provides a unique benefit and should be considered when kicking off a project where Python will be utilized. If you recall in Visual Studio Code, when I hit Shift-Control-P to bring up the command palette and search for Python, select Interpreter, depending on which interpreter above or many others out there you have installed, will allow you to select how you want to compile the code you are running. Before moving on in this course, there are a few more Python-related tools I thought would be worth mentioning here. The first is pipenv. Pipenv brings the virtual world of virtual env and pip together in one tool. This allows you to manage your projects in a controlled environment, and as you install or uninstall packages, it automatically updates the pip file, which is basically a running list of the dependencies and libraries used in your project so that anyone who comes along can quickly pick it up and continue to build off it. Python Poetry is another third-party tool for managing projects, packaging, and dependencies. You can easily set up the project with a virtual environment using the executable you want to build the Python project in. Finally, PyEnv helps you to quickly contribute to different projects built on various versions of Python. In addition, it allows you to switch between Python versions on a single project so you can quickly test your code out across multiple projects, or even better, upgrade your script faster to the latest version. Okay, so that is a little background and setup for this course. Why is Python important to the information security field? Well, it is powerful, yet easy to learn. It has modules for a single desktop, network, or even online. Everything a security professional has vested interest in. And because you don't work in just Linux, Macs, or on Windows systems, Python works across multiple platforms. You would think it would take months to secure a budget for such a powerful tool, but the best part is it is free and open source. And not only that, it comes with a wealth of third-party add-ons to boost your productivity. No matter your role, there is a benefit to learning Python. In this course, we'll talk through some of the more important libraries you need to know about. Now let's dive into some of these standard functions that will benefit your work. Before we get into the heavy stuff, let's take a look at some of the built-in functions that are either directly available or at most need to be simply imported without the pip install first. The following clips can be found in most Python training and are some of the more common functions you will likely see in your cybersecurity scripts. Especially in an analyst role, you'll be dealing with input that comes from a ton of various sources. On top of the fact you need to be mindful of the input and output requirements from the functions we will be discussing. Let's talk a little bit about the most common data types first. There are three defined types of numbers: integers, float, and complex numbers. Complex is used in arithmetic, graphics, and other deep math functions. Not something we will really get into in this course. Float, also referred to as doubles, are numbers containing a decimal, while integers are whole numbers. Boolean types are one of two values, true or false, sometimes represented as 1 and 0 when characterized as a number. Primarily considered in if statements, loops, and other conditional expressions that determine the path of the algorithm. Finally, strings, which is made up of data characters. They're assigned to variables through matching delimiters. Strings will be the most common data type you will work with, so let's dive a little deeper into this group and understand everything you can do with a string. I want to focus on 4 key areas you will likely need some background and education on to get the most out of your scripts. First, understand the index of the string, how to slice it, how to combine or concatenate it, and finally, formatting, which is all about controlling the output when printing a string that will contain bits that may change. So looking closer at indexing. Like everything else in Python, strings are an object variable that contain data, or more specifically, character data. This means strings are made up of the individual characters and hence can be indexed starting with 0 as the first character. In this example, the str variable is assigned the string Python, all uppercase with a white space at the front and another white space at the end. I just want to point out I'm only using a single word string in this variable, but it is very realistic to have full sentences and beyond assigned to a string variable, with each character of that sentence being assigned a place in the index. Let's play with this a little. This image represented in code would look like this: str equals Python with double quotes and white space surrounding it. Printing out individual characters of the string, I can see the character at the 0 index, or very first character in the string, is the first white space, followed by the capital letter P at the 1 index. Similar to how the index starts at 0 for the first character of the string, the last character of the string can be represented by the -1 index. In this example, -2 is the character N in the string. But that white space is ugly, so let's clean it up a little bit. It is not a simple reassignment of the 0 and 7 index in the string, as it is immutable, meaning that individual bits cannot be replaced. But what I can do with a method called slicing is select the parts I want of the string and either assign it to a new string or reassign it back to the original, replacing both the actual string itself and also its place in memory, with the new string cut down. Again, str equals Python with the spaces around it. But now, using the list bracket to call out what index I want, I can input a range that will give me all the characters in the range and assign it back to the str variable as I'm doing here. And as you can see, then prints out Python without any spaces. The central colon sets up a range, and if you want to start at the very beginning or capture until the very end, leave that end of the range blank, and Python will start capturing characters all the way to the end on either side. Slicing comes in handy when you have a formatted log that has a very specific formatting to it. As you read in each line of the log, the text for that line becomes a new string. I can then slice out specific parts like data and time, server, account name, or any other information if I know where in the string that information may live. Another useful string function that is important while searching log files is the operators in and not in. This allows you to determine if a set of characters is found anywhere inside another string or not. When parsing a log file, the in operator allows me to pull out all the lines that the user unsuccessfully logged in. Or if I am looking for a specific activity from a particular user, I can pull out every line that user was found in. Maybe I want to pull out all the pages that threw an error, but I don't want to focus on any one error. I can use the not in operator and ignore all the lines with the 200 status that successfully loaded, giving me the logs for the errors encountered. The plus sign operator is not just for math and allows you to combine two strings together into a single new string. This can be useful when you are wanting to construct an email address. If you know that the format is the first name plus the last name plus the ASCII and domain, you can basically extract information out of a CSV file and create a new column in the database for email with it. The star operator allows you to display a string however many times the number on the other side of the operator is. I have used this to display an ASCII bar graph in the past, give you a visual representation of how many times the status shows up in the log. Displaying a string can be as simple as a print of hello world in or two parts as shown here. Python also has available a %sign operator which allows you to display values in a string of a specific type, but requires you to know and select the right format symbol. In this case, %s is a string and will cast string on whatever is in the format parenthesis. In the next example of formatting string output, the format method can be invoked along with the curly brackets and act in the same manner as the format symbols, except this time they are simply a placeholder and you don't have to worry about selecting the proper format symbol. In the first example, we drop two placeholders, and in the format parentheses, two strings to drop into those placeholders. The brackets can be considered objects and allow you to order your output. In the second example, I am placing a 1 in the first bracket, signifying the second format element, and a 0 in the second bracket, signifying the first format element. This is good when you want the output to contain the element multiple areas of the output string. On top of all the functions, methods, and other elements of strings that we have talked about, there are a few additional functions I think will be beneficial for you, or at least for you to be aware of and research on your own to understand how you may want to incorporate them into your code. Index works similar to the operator we just discussed, but instead of returning a Boolean, it returns the value of the index where it was found in the string. And where index returns the first value of the placeholder for the first instance in the string, the R-index returns the place in the line for the last instance in the string. The join method, similar to the plus operator, joins all the values entered into the parentheses as a single string separated by a string calling the function. When looped while pulling information from a database, if the string calling the function is simply a comma, this is a quick and dirty way of creating a CSV file. Strip, lstrip, and rstrip remove the white space from the two ends of the string. Strip applies to both ends, lstrip works from the left or the front of the string, and rstrip works from the right or the end of the string. The split function separates out your string into a list. Unless specified, it will split the string at various spaces in the text. If you are using the function on a CSV file, for example, you will want to split with a comma set as the optional separator. Finally, count returns how many times the supplied value is found in the string. As we get into the demos and start playing with the packages and libraries we will be talking through in the next module, these set, mapping, and sequence data types will be discussed more and more. We've already touched on lists a couple times while discussing strings. The biggest difference between the four types is that tuples are immutable, meaning the individual items that make up the tuple cannot be changed, added to, or removed from once it is created. If you want to change the values, you basically have to recreate the entire tuple. This means tuples are collections that are ordered and unchangeable. Now lists, sets, and dictionaries, although similar to tuples in that they hold many values in an array of sorts, are in fact mutable, meaning the values in the container may change individually. Think of it as a class in other object-oriented programming languages. Lists and sets are used to store multiple items in a single variable, but sets are not stored in any specific order, and are not indexed, so you cannot change a specific item directly. When loaded, they will pop from the container in random order. Dictionaries allow you to store multiple items like the rest, but the values are stored tied to a key. Instead of calling the index number to retrieve a specific value, you call the paired key item. Okay, in this demo, we're going to take a quick look at some of the string functions we just went over and understand how to apply the methods and functions to this course. I have my variable str assigned Python with the spaces around it, and I've highlighted with these brackets in the print function, so when I run this, I see the spaces in Python string in the results. We talked about a few different ways of removing those spaces, and one way we didn't go into in great detail in the slides, so I want to kind of talk about in the demo, is to show you the strip method. By calling the strip method and assign it back to the str variable and printing it, I've now removed all that white space on the edges of the string. Another method we talked about in the slicing and dicing section was adding the range to the index, so only to display the parts of the string we're interested in. So I'm able to print the sliced out part, but because I didn't assign that back to the str variable, it's still going to have those spaces for the next time I go to use it. Now, how do I apply all this to a log file we're looking at? Well, a line in the log is going to contain all sorts of useful information that we need to parse out. Most of the time your sim will handle this, but if you're wanting to grab a one-off file and quickly retrieve some needed information out of it with the script, here's a quick walkthrough of some of the functions that can help here. The split method is another tool in the toolbox we didn't really cover, so I want to demonstrate using it here in the demo. By calling split without the parameters, I basically took this log file and broke it apart by the spaces inside the string and assigned each of those pieces to the list I called parts. Each of those parts are now indexed, and because of the uniformity of the log file, I know index 0 is the date, 1 is the time, and so on as you see here. Instead of the straight printing of each, I'm going to go ahead with the format printing and drop the brackets where I want to include the relevant list item in the output. As you can see, on January 1st, Mike W. was able to successfully log in. In the next clip, we're going to talk about reading multiple lines from the log and being able to cycle through to pull all successful and, more importantly, unsuccessful login attempts. To take the slicing a step further, I can break down the date and rearrange the content into a format I may be used to. Here we have month, date, year, and to get it into day, month, year format, you'll require a little bit more manipulation. A rather important use of Python in the cybersecurity space is to automate the handling of files. I may be retrieving information in a log file, malware analysis, reading in the CSV file to process work, or many other automation-inspired reasons. Before being able to read from or write to a file in Python, you must first open it with the open function, which includes the location, name of the file, and method or mode for how you want to handle the file. The R mode is the default if no mode is specified, and opens the file in read-only mode. This gives you access to see what is inside the file, but not overwrite or add to the file. An error will be returned if the file is not found at the location specified. The Python language does have a try except feature that allows you to gracefully handle the exceptions if the file is not found. W mode opens the file for writing, but not at the end, but rather at the beginning, meaning if the file already exists, it will erase and overwrite the file. In the case the specified file is not found, it will simply create it. An item of note here is that it does not wait until the first write to erase it. Simply opening the file with W mode will erase the previous content. A mode is an append mode, again allowing you to write to the file, but this time starting at the end and not overwriting the file. Adding a plus on the end of the mode allows you to both read and write to the file, but the W plus mode also overwrites the file at the start, allowing you to write new content and then also allowing you to read it back later. X mode creates a file if it does not already exist, but returns an error if it does. This is useful so you don't accidentally overwrite a file when creating it. Adding a plus B on the end of the mode chosen will allow you to read or write in binary instead of text. Once the file is open in read mode, you have a few options on how to read in the lines. The read method will read the number of bytes specified. If no bytes are specified, it will read in the entire file. The readLine method reads in the file one line at a time, whereas the readLines method reads in the entire file up to the specified number of bytes called in the parameters and drops it into a series of lists. If no byte count is specified, it will read the entire file. The write method will add content from the start of the file. Each additional write called in the script will continuously append to the end of the previously written line. The writeLines method will write all the content of the list to the file. It is important to note that subsequent writes will continue on the same line previously left off. If you want every write to start on a new line, be sure to add /n to the string about to be written. We will talk about how to delete files once we discuss the OS library, which we'll get into in the next module. Here's where we start to go from the built-in functions to dipping our toe into the modules and libraries Python can offer to expand the power of the tool. The subprocess module is part of the standard library, but it needs to be imported in order to take advantage of the functions inside of it. The subprocess module allows you to kick off new processes or applications and connect to different input and output pipes. The run function was first introduced in Python 3.5 and is a simple and easy way to run your basic commands. Simply pass the command you want to run, for example the ls on the Linux box. The command will open a shell and pass the command value, then return the script and move on to the next line. Each of the functions here executes a subprocess slightly different. I would recommend, as you start to build out your script, you start with a basic run or call command and see if that handles the call the way you expect, and work from there. Each of the functions process the command slightly differently, but all handle the same set of arguments. The standard in, standard out, standard error are what you expect. Details on the command's input, standard output, and standard error handling. The shell argument, which defaults to false, specifies whether to use the shell to execute the command, which means the command must be formatted the same as you would at the shell prompt. This option gives you the access to additional functionality available in the shell. The CWD current working directory argument changes the working directory, allowing you to open programs and leave output in a specific directory when finished. Now there are other arguments, but those are not as common across. A distinct difference between all the functions is how they handle the timing of the commands they are running. Do they kick off immediately, move to the next line in the script regardless of the outcome of the subprocess, or do they wait before moving on? In some cases, the same function will behave differently based on what command or application is being opened. In this demo, I'm going to run through a few of these and show you the output. To be honest, not all that exciting of a demo so far. As you can see, each of these pretty much run as expected while running commands from the command prompt. Now where this gets a little tricky, and I will open it in the command prompt to make it easier for you to read, is when we start a new process and call an application from that prompt. In the first example, I'm calling out an OAuth tool called Zap and asking it to kick off a passive scan of example.com. So while I run that, think of some of the possibilities of where you can set up scripts for your dev teams to run that will scan the lower environment application they are developing and return a log of potential issues to the screen. Now, we're not going to go through all of that right now, but one thing I did want to point out is you see here, as soon as I ran the script, the finished text displayed, and even though Zap application is still running. Now let's start a new process again, this time of a different application. We're going to go with notepad.exe, and when I start this script over again, you will see the subprocess kick off to open Notepad. But as you can see, the finished text hasn't displayed yet. The text won't display until a Notepad process is killed. So that is why I said make sure you test it and play with it to make sure it is running and responding as expected throughout. Back to the Zap executable, but instead of kicking it off with the run method, I'm going to kick it off with this check output method. It is the method that determines the outcome of the subprocess executing before moving on. So unlike run, which immediately moved on in the script, the checked output method is waiting for the Zap tool to close. Now this is where you can run a scan and dump the output into a results folder, at which time you can have a script redirect you to the folder and start to parse the outcome without having to run a new script or rerun the one that you just finished. It wouldn't be a security course if we didn't discuss encryption and hashing functions. The two main modules I want to discuss are base64 and hashlib. Base64 needs to be imported and pretty much does what you expect: encode or decode a string in base64. Base64 is a very common in websites to embed heavy amounts of data into a short, quick string. It is also used to convert binary to ASCII strings for storage and transfer. In this demo, we're taking a look at the string, "Hello, my name is Michael Woolard," and encoding it into a set of bytes. The B64 encode function processes these bytes and outputs a base64 encoded set of bytes, which we now run through a decode function to produce the string to be printed. The second part of this is to decode this base64 encoded string back to the original text by reversing this process. When I run this script, you will see I have my original text, the base64 encoded version of that string, and then back to the original string. Now onto the hashlib module. Basically the same principle, but there is a few options to consider. I laid two of them out here with SHA-256 and MD5. Neither of which should be considered strong for storing passwords, but are the two functions I pull out of the library to help demonstrate. We start this demo by importing the hashlib module and assigning a string value to a str variable. "Hello, my name is Michael Woolard." Same as with base64, I have to encode the string into a set of bytes that allows me to call the string with the SHA-256 function. Now in this print statement here on the end, I am using the hex digest function, which converts the output back into a string that can be printed on the screen. Here's the SHA-256 value of my "Hello, my name is Michael Woolard." Now let me switch the comments. And here is the MD5 value of that text. MD5 is interesting because it is commonly used both online and offline for integrity purposes. Never confidentiality anymore. MD5 is beyond broken at this point. But one use of MD5 is when you're downloading software. You want to verify no one has tampered with the file before it made its way onto your machine. Software distribution services often provided MD5 hash value of the file for you to compare the downloaded file against. Now back in this demo, let me come out some of the top sections first and open up the bottom for processing. As you see here, I am first printing out the hash that comes from the website I downloaded the file from. I'm then looking to open the Python install file with this RB option so it assigns it to the f variable as a set of bytes. The code then runs the bytes through the hash function, which then spits out the MD5 value of the application I just downloaded. When I compare it to the hard-coded hash from the website, I see they match, and we are good to sign off that the downloaded file has integrity. Not a bad little tool you can provide your team to verify documents before they are opened on the desktop. In review, you'll be working with all sorts of data types in your security projects. Knowing how to handle that data, how to convert the data to work with the functions you need to use, and how to gather, group, and sort the data is a big step forward. To get to the data, we have to understand how to work with the files that contain the data. There are all sorts of built-in functions to opening, reading, writing, and deleting files. Use this to your advantage to automate malware analysis, log processing, or writing and parsing things like CSV documents. The ability to kick off a new process is a huge advantage of Python over other languages. A phishing email with an attachment came in. Your script can now automate the process to kick off a scan with various tools of your file. Then start your sandbox to further break down the macros built into it. Finally, encryption and hashing. What security pro doesn't touch these regularly? Personally, I generally get more into this area with my web application assessment work on that side of the house, but I pull all sorts of tokens and cookies out and process them and learn how they are constructed and recreate the token with the information I was passed. We will talk a little bit more about this topic towards the end of this course when we start to get into the discussion on monitoring net traffic and sockets and dealing with the encryption there. Python libraries and modules extend the capabilities of Python into the subsystems, networking, and all the other system functionality you need as a security professional to monitor, test, and secure. Let's start with a few of the standard modules built in and work our way into some of the more complex third-party libraries you will need. The sys module is our first built-in module we will walk through today. Yes, we still have to import it into our script, which we will show you in a second, but the module does not need to be downloaded or installed with the pip first. Details on the module can be found directly in the python.org site. Each function, including some of those we have already talked through, are broken down with some of the more important details on how to implement. You do not get every final detail, so if there's anything intriguing to you, I would suggest researching deeper to understand what versions of Python the function works with and what all the function is capable of doing. Some come with multiple parameters and nesting abilities to expand on other functions. As mentioned, this is part of the standard library and does not require you to download, but does have to be imported. So what is sys? Well, it is a set of functions that allow you to interact with the interpreter. Taking a look at a few of these, there are a few dozen, so be sure to use the link to the official sys module documentation, but some you might see in your work, argv, which allows you to access any command line arguments when kicking off the script. These are used to turn static scripts dynamic without having to hard-code your changes. Just note, these are not inputs requested while the script is running. You will use the input function for that. But rather, these are command line arguments added to the start string. An alternative to sys.argv is the library argparse. Argparse helps to automatically parse all the command line arguments and assign them to variables to be used. But for this course, I'm going to stick with the argv as it is a more straightforward approach. Path is a list of everything loaded into the path environment variable of the operating system. This orders the various paths in a list, with path 0 being the directory containing your script. The standard error is part of a series of standard in, standard out, and standard error inputs and outputs. Standard error is important because it will alert you when any part of your script has an issue so that it can be addressed. Version provides you with both the build of the interpreter used, as well as some additional information on the operating system architecture. You can use this to view, but I would suggest using version_info, which will break down the information into a list that you can use to help you determine if the user is running a supported build for the script. All right, we're going to walk through a quick little demo of the sys module. As we talked about, you simply have to import it to use the functions of sys. One of the major functions that we kind of pulled out here was talking about the standard in, standard out, and standard error. You know, when we simply go through and print those messages to the standard out or standard error, you're going to see everything prints directly on the screen. And that's all fine and dandy, but you ask yourself, well, why? What's the difference then? Right? So what we're going to do is we're going to take the standard error, and this time we're going to print it to a log file. And as you can see here, I'm printing it to a log file that sits within the same directory, and I don't have that log file currently. So when I run the script, the only thing that prints out on the screen now is my standard output, and all my errors have disappeared. Why have my errors disappeared? Well, as you see here, it's created that output error log file. When I open it, you see all the error messages are in there. Going back, I could also comment out my standard out. So now when I go to print, all my standard output and my standard errors, let me delete my error file here. My standard out and my standard errors have all disappeared. And now you see I have an out error and an out. And inside the out, I have all my standard outs. And inside there, I have all my standard errors. So that's one way of kind of like splitting it up. If you want all your error messages to go into a log, if you want all your error messages to print on a screen and you want your output to go to a log, there's a lot of different combinations you can take in to kind of split up where you want your output to go to based on the error message, based on standard out. So we're going to get rid of all this now. That was a quick little demo of that. And we're going to talk about the input. So standard way of inputting is, hey, I'm going to ask you for something, and then you type that in, and I'm going to do something with it, right? In this case, I'm just simply printing it on the screen. So let's go to this demo now, and it's going to ask me, hey, what's your name? I'm going to put in Mike. And it's going to say, hello, Mike. But another way of kind of going through this is to say, tell me who you are, but enter that as part of calling the script. And so it says that argument, I'm going to say hello. So now when I call this script, what I can do is I can add a space with some arguments on the end, one of them being my name. And when I hit enter, it's going to say, hello, Mike. So it grabs that and prints it. So looking at this uncommented, so I have two ways of inputting here. I have entering it directly into the script and entering it as part of the call to the script. So when I enter it as part of the calls to the script, I could put in John here. And when I enter it into the input of the script, I say Mike. So I have hello Mike because I grabbed it from my input, and I have hello John because I grabbed it from my argument that I added as part of calling the script. One thing I also want to call it here is if you want to have a name, file, whatever the case may be that you're entering here with a space in it, you need to put quotes around that so that it simply calls the entire thing now. So hello, John Smith. If I were to forget those quotes and I hit enter, and I type in Mike, it's just going to say hello, John, because it's going to treat those as two separate arguments. So we're going to get rid of all that. Now we're going to look at the next item on the list here. So we talked about the path, we talked about the version, and we talked about version info. So these four items are really two different ones. The path talks about your system variables. Adding that 0 onto the end of it just pulls out your main working directory. So what am I working off of for this script? The path pulls out the full path from the system variables. Version pulls out what version of Python you're working off of, all in one line printed out. And version info prints out all the different parts into separate areas. So your major version, your minor version, it will print all that out into separate parts on the screen. And so when I go to print this, what you're going to see here is at the top, I have my working directory. So that's the path I'm working out of. I have my full path, which is everything in my system variable. I then have my version all laid out nicely here on one line. And then I have version info, which breaks up that version into your major, your minor, your micro releases. And what's nice about that is if you're writing a script that's written for a very specific version of Python, or only works up to a certain version of Python, needs a certain version of Python in order to work, you can take a look at this version info as part of your script and throw out an error message or throw out some type of warning saying, hey, this script may not work because you're using the wrong version of Python. The OS module extends the reach of our script from the interpreter to the operating system. Not to sound like a broken record, but as with the sys, details on the module can be found directly on the python.org site. Each function, including some of those we have already talked through, are broken down with some of the more important detail on how to implement. Some of the functions come with multiple parameters and nesting abilities to extend the function. As mentioned, this is part of the standard library and does not require you to download, but it does have to be imported. So, what is OS? Well, it is a set of functions that allow you to interact with the what else operating system running the script. Taking a look at a few of these now. The open, close, and remove functions allow you to interact with files on the server. Something as standard as maintaining a log for the script running or diving deep into the security world and open a file to check for malware, reverse engineering a virus, or importing a definition to crack a password or compare a Yara file. The getCwd function returns the current working directory so you are able to jump around in case you want to access files in other directories. getPID will return the process ID of the current running script. When we start to talk about the psutil library next clip, we will get into how to pull back the PID of other processes which may be useful in understanding what is running on your machine. Finally, in this section, we will look at system, which will allow you to run command line functions. Having communication problems to a server? Want to ping or trace the route? It is possible. You can kick off executables or perform any of the standard uses of the command line you can think of. Very powerful tool here. One item of note, the subprocess module intends to replace the OWASP.system as it spawns new processes. I still use the OWASP.system today, so I will demo it, but you'll want to learn about the subprocess module we covered in the last part of this course. Okay, let's run through a short demo here of some of the functions we just covered and see how we can combine them with the methods and functions from the sys module we covered last section. The first couple here, getCwd, or the get current working directory, should show me the directory this script is being ran out of. The getPID, or the get process ID, will return the process ID of the executing of the script. And the OWASP name will uncover the name of the operating system I'm currently running on, which I will say is kind of limited, so there's only so many that are registered on there and will be returned. So I'm going to throw in there the sys.platform to show the difference, as the platform can go a little bit deeper. All right, so I'm in here now. I'm going to run this. Okay, so here is my current working directory. So I made mention that I'm working out of a folder on the desktop called Pluralsight before. So this script is being ran out of that working directory. Here is the PID, or the process ID, of the execution of this script. Next up, we have our operating system, so NT, as you see there, and then I called the platform, which can dive a little deeper, and that's showing Win32. Okay, next we're going to talk about being able to use the system function to call out commands. Here I am running a ping just of the local host, the 127.0.0.1. So when I run that, you'll see that the ping is going through. Coming back into the code, I can also run a ping of an IP that I add to the arguments of the script. So if you have a server acting up or needing to be audited or checked, using the arguments saves you from even having to hard code and create different scripts for different servers. Not have to have a specific server in the script. So I'm going to run this against the 127.0.0.1. And as you can see, just by the arguments alone, it's going to pull that and start pinging it. All right, in the last demo, we talked about opening a file and writing to it. In this case, I'm reading the log.txt file, and I'm going to display it on the screen. So I'm going to go through that, and you can see that this is all the contents of that log.txt file. But how do I delete a file? That's where the OWASP.remove comes into play. So when I call this remove, it's actually going to look for that temp.txt file, and it's going to go through and delete it. I can add directories in here if I want to delete a file in a different directory. I just need to make sure that the script has permission to access that file and to delete it. But once I run this, you'll see that that temp.txt file has disappeared. And then finally, a few functions we haven't really talked about too much as the walk, the path, and the join. As I enable this, what you will see is when you execute it, all the files and file structure of that Pluralsight folder I'm running on the script out of. This includes all the buried Yara rule directories. So as I go through and scroll through here a little bit, you're going to see all the different files and directories that are sitting in here are now displayed because I was able to walk through them all and basically print the path on the screen. All right, that's enough for now. Let's jump into the regular expressions library next. If you've been around coding and development for any amount of time, you've probably heard the term regular expression or the more common regex, probably the topic that frustrates people the most. So I'm not going to dive too deep and bore you, but just enough to unlock the capabilities to help you understand how it may be useful in your day-to-day life. The full documentation will by far help you more than I can in a few short minutes explaining this topic. There are people who have written and delivered full-day training courses just on regex. So, what is it? Well, more or less pattern recognition. Does the next line in the log file start with a certain character? Does this file contain a specific signature for a virus? There are many use cases for using regex in security. Most notably, I want to know if certain files on our servers contain a signature for a new 0-day. Or do we have the ability to locate and pull out notable actions in a log file? Just recently, I used regex to audit a data file from a production server our development teams were using for testing purposes. I was looking for customer personal information, including email, phone numbers, and addresses, spot checking whether the information was obfuscated in order to use the data as per our policy. The functions of the RE module are important, obviously, but I will start with the regular expression syntax that includes the special character and special sequences and can be found under the regular expression syntax function of the python.org documents of the read module. These characters and sequences are at the heart of how regular expression operates. With regex, you are basically doing a string comparison and laying out the format to say, if this string matches this pattern, do something. If not, move on. Standard ASCII numbers and letters are the simplest form of comparison. Does this string contain this specific character or characters in this order? The special characters, also referred to as meta characters, are a layer of rules that sit on top of the patterns you are trying to find. For example, the question mark placed beside the pattern states this pattern must be present 0 or 1 time only, but not more. A plus sign states the pattern must be present at least 1 time in the string, and the star states that the pattern is basically optional to the string. I will show you a few examples to hopefully clear this up in a second here, but first, I want to also talk about special sequences. The backslash plays a significant role in regex. It tells the tool to escape, meaning instead of literally looking for that lowercase d character in the string, instead it will match this pattern if it encounters any digit 0 to 9. In this example, I'm looking for the pattern /d/d, meaning 2 digits. But the special character attached to the second sequence tells the system how to treat that second digit. The asterisk states the character pattern is optional, yet okay if it's repetitive, and will return the full number. The question mark only wants the pattern if it's specifically 1 character, or digit in that case. And we'll pull the 30 out as it has 2 digits, then the double 0. Finally, the plus sign wants 1 or more, so it pulls the full part of the string that lines up. So what's the difference between the asterisk and the plus symbol, you ask? Well, looking at the new short string with this same pattern, the asterisk returns it as it requires 0 or more, as does the question mark. But the plus symbol, which requires a minimum of 1 match to fit the pattern, will not return anything. Regex can be so confusing, no doubt. Finding the right pattern match will take practice and a lot of testing. Notice the R at the front of the string? Well, that's to signify I want the raw text to test the pattern against. You don't want Python functions escaping characters and not displaying what it is you think you are getting. The R tells Python to display the backslashes and anything else that may accidentally change the input. The syntax makes up all the patterns which are at the heart of the regex. How those patterns are used to find and manipulate the information, well, you'll need the functions. Compile is when you're using a pattern in multiple areas. You basically write your pattern once, drop it into the compile function, and assign it a pattern variable, which can then be used in various search functions. The next three, search, match, and find all, tell Python how to find that pattern. Match searches at the start of the string in question. Search will look for the pattern anywhere in that string, but only returns the first match, while find all returns all the matches of the pattern. Definitely 100% ways of manipulating even that, and there are functions like split and replace that fall more on the string manipulation side. But for security, you are going to focus more on matching and searching than any type of manipulation action. All right, jumping into this regex demo, we're going to take a look at some of the more important functions of the regular expression. One of the first things you need to do is import the RE module. That's what brings all these functions into the script. I did include the string that we're going to be parsing today. Normally this will be more of a dynamic input coming from a log file or some type of input. But I thought it was important that we had the string here in front of us so that we can take a look at it and understand what we're trying to do, what we're trying to parse out, what that looks like in the string itself. So the two patterns we're going to be looking at. The first pattern is our result pattern. We're going to be looking for the word success, followed by that /w and the asterisk. So the word success is quite literal, the word success. The /w says I want to get all the alphanumeric characters that come after that word success. And then the asterisk means however many there are. So this is going to pull the word success. It's going to pull the word successful. It's going to pull the word successfully. All different common ways of describing an accepted login attempt. The next one is the date pattern. So the /d means I'm looking for a digit. So I'm looking for 3 digits, all separated by a slash, and they're all going to have that little plus symbol on the end. It's signifying that I don't care how many digits there are. So it could be 1 or 2 or more. But I'm basically saying this could be in day, month, year format. It could be in month, day, year format, or it could be in year, day, month, or year, month, date. However the format of the log is set up, this should be able to take into account all those different combinations. We're then going to take those result patterns and we're going to compile them down so that we can store these patterns into a variable of their own so that they can be used within the functions. So this first section we're going to be looking at, we're going to be running through a match function. So match, as you recall, looks at the very start of the string, and it's going to say, does this word success show up at the start of the string? And of course it does not. So I fully expect this, and the way I handled this is to basically, if it does come back as none, we're going to gracefully just print out the word none. Otherwise we may get an error, the page may fail, the script may fail. So we don't want that to happen. So we're just going to print out the word none, which I fully anticipate it happening. We're then going to run through the search function. So the search function looks anywhere within that string. It's not just at the start, but it basically starts from left to right and looks for that word success anywhere within the string. It then returns, did it find it? What did it find there? It returns where it found it, and then also the date. So we're also using that second pattern of the date pattern to also display the date. So let's run this real fast, see what happens. So we do in fact have that the match returned to none, which we were anticipating. But then the search returned the name of the string. It returned the word successful. So that's more than just the success. So that's showing that we actually found the full response from the log. It started at character 35. So as you recall, starting at character 0 all the way down. So right here is where 35 would be. And then date, we were looking at the date, which is in that first set of characters. It was able to find that pattern as well and return it. So jumping back here into the script, we're going to go through and clean this up a little bit. We're going to change some of our comments around so we can comment that top part out again. We're going to look at this bottom example now. So similar to what we just did, we looked for that pattern. We pulled out the pattern of the date. We pulled out the pattern of the results. Another way of doing this is to split that string. So if you recall, the string at the top had a date followed by a space, then a time followed by a space. If we're able to split this whole string up by those spaces and assign each of these different parts of the string into a list, basically what we're doing here is saying print out all the tokens, so each individual part of this list. We're then going to say give me token number 4. So starting at the beginning, token 0 is the date, token 1 is the time, token 2 is the user, token 3 is the page, and token 4 would be the result. And then followed by that, we want to go back to token 0, which was, as you know, the date. And then finally, after that, we're going to do a find all. So similar to the search, I'm looking for this pattern. In this case, I'm looking for a single digit pattern throughout the string. So anywhere that this pattern is found, it's going to drop that into a list and return all the results. So this is good when you have something you're looking for multiple times within a single string. So in this case, we're just looking at the digits. So I'm fully expecting it to return all the digits from the date and all the digits from the time when it returns. So let's save this, jump over here and we run it again. So when we do our split by the spaces, you'll see that all the tokens prints out each individual part of the string into its own separate item in the list. Item number 4 is in fact the word successful, and item number 0 is in fact the date. Then down below, I'm splitting out that string into a list and giving me every single digit in its own list item. PSUtil, pretty sweet utility. Well, not really, but that would be funny if it did stand for that. But the Python System and Process Utilities is a cross-platform library for retrieving information on running processes and system utilities. It is our first library we will need to pull down and install with a pip or your installment method of choice. At the PyPy website, you can find information on PSUtil, download the files, and find documents and forums to discuss the library and learn how others are using it to their advantage. On the readthedocs.io PDF link, you can get a full detail of the functions included in the library. Here's a quick look into the material. As you can see, not only does it talk about the functions, but also some of the detail of the parameters in those functions. A truly well-documented library. So what is PSUtil? Well, it is a library that lets you get into the system functions and processes to see metrics and other details on the CPU, memory, disks, network devices, and various other sensors. I probably don't have to go into too much detail on how important this can be to you. The ability to not only see processes running, but be able to find the process by name and pull it back with all its detail on it. As an analyst, you may want to monitor what processes are running on a server and what network connections those processes are making. You can then take this baseline and run a script around the clock regularly and compare the results in order to find unusual activity. The functions within this library are what we're going to focus on to gain you your insight. Net_connections will give you all your open socket connections, broken out into tuples containing all the key pieces of information for each, including the local port, the remote IP and port, and the PID that opened the socket. This is huge when monitoring suspicious software you are testing in a sandbox. Process will return information on the process that called it, or if the PID is specified, information on that process. When used in conjunction with the one-shot context manager, you can pull all the details back in one call, dramatically speeding up your work. CPU, disk, and virtual_memory all pull the metrics on the various parts of the system specified. All right, so let's take a look at the PSUtil. This is going to basically cover all of our system and process utilities, as you know, all the metrics and whatever is going on within our systems. It does require the pip install, so we have to do the pip install the PSUtil. That will then give us access to be able to import the PSUtil that you see here, which then gives us access to all the functions and methods and everything below that. So the first thing we're going to look at is net_connections, and then the users, and then the PIDs. So the net_connections, your network connections, and I did point out in here under the parameters that I want kind equals inet4. inet4 says I want all the IPv4 connections, so this way it doesn't pull back everything, all my different networking. And I added the 0 onto the end in the list because I want to only just pull back one. It's going to give you every single inet4 connection. I just need the first one just for demo purposes. The users is going to pull back all your connected users. Mine should just have my user. So if you do have a server that has multiple people logged in, it will pull back all the users that are currently in there. And then the PIDs is just all your process IDs of all the running processes right now. So let's jump over into a demo of this right now. We're going to run that, and we're going to see our network and the network ID. We're going to see the users that are currently logged in, which is just the one standard user right now, and then all the PIDs. So let's jump back into the code and we can dive down a little bit deeper into that. So let's uncomment this out. And basically what we're going to look at now is our process iteration. The process iteration function allows you to select, hey, I want the process ID, I want the name of that process, and I want the username that's running that process. I can then take that information and I can print all that out on the screen. And that gives you a cleaner list of what is going on. It's not just process IDs that mean absolutely nothing to you. This actually dives into a little bit about like what is each of those process IDs. So we see each of these, and now we can take one of those. So I'm going to take, for example, we're going to look at the SV host 1948. And back in the code over here, I can even dive even deeper into that now. So I have psutil process that I could put that 1948 into. And I say, give me all the information on this one particular process. So this one-shot function then allows me to pull back the name, the CPU time, CPU percentage, the crate time, parent PID, and then also the current status of it. So when I run this now, I have all that full list of all the PIDs again, and then I have this SVC host process and all the information on that particular process. So it allows you to dive into various processes, understand who their parents are, understand like how this process came about. So jumping back into the code here, I'm going to take this a little bit farther now. And we're going to jump over from looking at processes to looking at our CPU and our system information. So we're going to comment out everything here at the top just to get that out of our way. What we're going to look at next is the functions that allow us to look at the CPU times, CPU percentages, virtual memory, disk usage, more virtual memory, more disk usage, the partitions, the users, and the boot time. A whole bunch of functions here. I'm just going to go ahead and run it. And what you're going to see here is all that information we just covered. So, what is the CPU, percentage of the CPU in use? What is the percentage of the memory in use? Going through the whole 9 yards, a lot of good information about what is going on within your system. So these types of functions can be used within an analyst role when you want to kind of monitor various systems. You're starting to get some alerts and different things popping up on the system. You just want to pull back all the different processes and what's running on those systems. The last piece I want to look at here, pulling processes by name. So one of the processes that are in there is your WinLogon. So when I do a search now of that WinLogon process, it pulls back just the information on that WinLogon process. This is useful when you're going through this whole process list and you see a process you're not understanding, what is this? What is it doing? Who are its parents? Where did it come from? So a lot of good information that can be used by your networking, your analysts to research what's going on within your systems. The cryptography package contains what is referred to as recipes for symmetric encryption and hazmat materials, which are the low-level primitives. But we will not get into that today. The package also allows you to get your hands into the X509 standard, which we see a lot of in TLS certificates. As usual, I am providing you a few links with the full documentation on the library. Cryptography is one of those fields you either get it or you don't, and if you don't, I wouldn't suggest just figuring it out as you go. Sit down with the documents provided and really understand what the library is capable of. Crypto is the last thing you want to try to roll on your own. In this course, we're going to talk about the Fernet symmetric encryption provided in the cryptography library, which guarantees that a message encrypted using it cannot be manipulated or read without the key. And we'll talk about the script key derivation function that can be used for encrypting file and application passwords. Script is available as a primitive inside the cryptography library. The Fernet module contains a Fernet class, and yes, capitalization is important here. When we get into this demo, I will show you how this all relates. The module also includes a key generator. In symmetric encryption, the same key is used for both encrypting and decrypting, so managing this key is important. The Fernet class, when assigned to a variable using the generated key, is then able to encrypt and decrypt a binary. To visually understand this, the Fernet module has a Fernet class that can be assigned to a variable by using the generate key function built into the class to set a unique key. Once assigned, you are able to encrypt or decrypt any binary set in the parameter of the function. Now script, which comes from the same cryptography library, is buried in the hazmat primitives under the key derivation functions. Similar to FIRNet, script is a function under the script module, and instead of additional functions, this lists all of the parameters. Script is a little less complicated, but the script class does require a few additional parameters to develop the key. This is because it was built to be attack resistant. Salt is a random string added to the password to prevent hash passwords from matching up in the event that two users set the same password. Length is the desired length of the key that is derived from the function. N is the CPU impact that slows the attack down. This should be set to a power of 2. R and P control the block size and parallelization accordingly, and IRED is generally recommended to be set to 8 and 1 respectively. Alright, in this demo for cryptography, we're going to take a look at both the implementation of FIRNet, which is an example of symmetric encryption cryptography, and script, which is a password-based key derivation function. The cryptography library is a third-party library which requires you to run the pip install on cryptography, which will give you the ability to import the FIRNet class out of the cryptography.firnet package. Class method now available to you is the generate key, which generates a fresh FIRNet key every time called. You can then take this key, drop it into the class, and assign that class to the variable. Once that class is assigned, that variable now has two functions available to it, encryption and decryption. So I'm taking my message, encrypting it with the key generated, and printing the result. And on the next line, I'm decrypting that result using the variable that contains the key to get back to the original message. Taking a look at this in action, when I run it, you'll see I now have printed the key generated, displayed the scrambled message, and then back to the original unencrypted message. Now in the real world, you would want to pull out the generated key and store that securely with the person you are trading messages with. That will be the only key that can possibly be imported into FIRNet and used to encrypt and decrypt the same message. Script is a key derivation function designed for password storage, which will slow down an attack by tuning the memory. The class comes with a set of parameters. Salt is used to extend the password. This way, if any two people happen to set the same password, the resulting hash will not be identical. The salt should be unique to the individual, but can be stored in plain text, just not something you want to necessarily share with the public. Length is the desired length of the resulting key. N is the CPU or memory cost that will be a power of 2. R is the block size that is recommended to be set to 8. And P is the parallelization and is recommended to be set to 1. So once the class is assigned to the variable, I will then derive the key of the password provided. Once I store the key securely in my database, I can then make a call later, using the same parameter of the script class, including the same salt, provide the password, and verify the keys match. The verify function is used to raise an exception. If no exception is raised, it will simply return none, meaning the passwords match. So let's check this out. So now that I've run this, I see the key that was derived. I also see that there is no password exceptions, so that means my passwords match. But what happens when they don't match? Going back to the code, if the passwords do not match, for example, I left the exclamation point off the end here. I now run it again, and I see the keys do not match exception has been raised. These next few topics can literally be whole courses in themselves. I cannot possibly cram everything into a few minutes, so I'm only going to focus on the pieces I feel you will touch on the most in this profession and leave it up to you to research the rest on your own. As usual, project information is on the python.org website. Yara is not developed specifically for Python. It was developed by software engineer at VirusTotal to aid malware researchers and quickly disperse the detection information. When we talk about regex and identifying patterns, that is exactly what Yara was established to do. To find the patterns of various malware, making it easier to develop tools in languages such as Python to detect and hunt malware in your systems. An official full write-up of what is available for Yara can be found on the Read the Docs site. I have posted here the specific callout to the site of the Python implementation. Finally, in order to implement, we must first pip install in order to import. The Yara rule template is broken down as such. At the top, the name of the rule. Basically, what do we call this once detected? Inside the rule is your optional metadata, where you can put add-on information about the rule. Some examples used here include who is the author of the rule, when was a rule created, and last modified. There are no defined names here, but there are reserved keywords that cannot be used. The strings and conditions sections are the heart of the rule. The strings section allow you to define any variables which contain the pattern to be identified. Now think back to our clips on the regular expression. You can have defined text, hex, or pull out the regular expression sequences and define the pattern. The conditions section contains the defined expressions that will return a Boolean response based on whether or not the expression has been met. Looking at a few examples we pulled out of the public Yara repositories, the tofu backdoor is looking for a specific cookie, pipe, or set of hex, and if any of them are found, the backdoor has been discovered and returned a true result. The example _rule has a few defined metastrings, one of them being whether this is a threat in the wild, or actively being exploited, and what the default risk score is for that threat. Similar to the last rule, because of the OR operators throughout the condition, if any one of these strings is found in the file, the alert will pop off. There are just two functions we want to look at today. First, the compile function. Before you can scan a file, you must first compile the rules into a binary that can be pulled into a match function and compare the file or files you are wanting to check against the rules. When you have the specific markers an emerging zero-day threat contains, along with where in the file system is known to attack, you can create your own Yara rule and check systems with your own homemade Python script to conduct a threat hunt of your environment. With Yara, you will need to pip install the Yara package as it is a third party. Once that is ready, you will be able to use the compile and match functions. In this demo, I am setting the directory I want to scan and compiling the rule I want to run against that directory. In this demo, I am only compiling the one rule. This may be the case when you are checking for a known indicator of compromise. I then run a quick for loop of every file in the defined directory, comparing it against that Yara rule using the match function. If there is a match, I throw the file name and warning message. And in this case, if there is no match, I also throw the file name in a clean remark. Running this now, I can see it scan through all my scripts and return that they are all clean. This should make you feel better about downloading them later. Sockets and socket behavior has been around since before the start of network programming. Sockets allow communication to flow between processes running on the same or different machines. For this to work, we have to bind the socket to a specific port. When the socket is bound to a port receiving packets, the TCP layer knows which application is listening for that data. We will be covering quite a few functions in this section. The full write-up on all of them can be found on the python.org site, as the socket module comes standard and there is no need to pip install it. The lessons learned here are nothing new, but how can we take these things and use them in security? Well, I have developed many scripts over the years that conduct very specific tasks for pen testing, such as port scanning, various wireless access point attacks, and on the flip side of that, when a new server is spun up, a server hardening script is kicked off to audit the machine and verify things like what ports are open, are default accounts disabled, and some other basic reviews, so a human doesn't have to waste time on it. Looking at the functions, and there are a lot we want to cover, so let's run through these quickly. The socket function is what actually creates the new socket. The provided parameters allow you to define the type of socket it is. Bind then runs on the server side and takes that newly formed socket and connects it to an IP and port on the server. Listen does exactly what you would think. You now have a socket and a port assigned to a server. We can now listen for traffic on the binded port. Once packets are received on the new socket, the accept function formally accepts the connection and tells your code who the IP address talking to it on the other end is. Speaking on the other end, the connect function sits on the client side and tells the socket to make a TCP connection with the remote server via host and port. With different parameters, this can be a UDP port as well. Send and send all is the command to send a packet. Send is limited in size, whereas send all can handle larger packet sizes by basically breaking down the packet into chunks and using the send command over and over until all the bytes have been sent. On the other end of those sends will be the function receive that will handle the data packets by processing them as they come in. Once your communications are complete, it is customary to close the socket and free up resources. Sockets are going to be a rather complicated demo as there are many moving parts. I will try to explain everything going on, and for some I will just only cover the code and what's different inside of it versus previous runs as to not confuse you. The socket library comes standard with Python, so you simply have to import socket to begin. The first task is to set up a server. In the server script, we are simply echoing on the page everything that is sent in, so I'll start by assigning the variables for the loopback IP and port I want to listen on, in this case port 12345. The socket function will then be called with two parameters, the first to tell the system what network protocol, and the second parameter what type of socket, in this case sock stream, which will send and receive TCP packets. With the socket class created, I can now bind it to a specific host and port set above and open the listener waiting for traffic. This puts me into the ready state. I then start an infinite loop so that the connection doesn't close after the first communication from the client. This loop will keep the listener open and ready. Inside that loop, I will wait for a message using the accept function, which will accept a key piece of information: who sent the message. Once the message starts coming in, the receive function is called with a message size boundary. This loop will keep cycling back and call the receive over and over until the full message is pulled in. In my demo, if the message is disconnect, I display a disconnect message and break out of this loop. Otherwise, I tell the client I received their message and print it on the screen. Once the loop is broken, it will move and close the connection. On the client side, we are setting up with what host and port we want to communicate with, which is where the server script will be sitting, then opening a socket and connecting to the remote server and port. For this script, I will be dropping a message in the arguments so I can control what is sent. Messages are in bytes with UTF-8 encoded. Once sent, I then listen to see if the server sends anything back to relay to the client a successful connection was made, and I print that out. So looking at this in action, on the top here I have my server script. I'm going to set that to start running. You'll see that it kicked off and I'm in a ready state now. I'm then going to send off on the client side a hello there message, to which the server received it and sent back to say, hey, I received your hello message. I'm going to try that one more time just to show you in action that it's still looping. I'm now going to go through and send over a disconnect message to break out. So now I'm broken out of my listener. Another demo I want to get into is the port scanning. So the port scanning, basically, instead of sending one message, it looks at all the different ports and sends a different message over the different ports and says, hey, are you listening? If it comes back with the result of 0, that means that it's open and that it'll print out to say this port is open. Otherwise, it'll just simply print the port name. So looking at this, again, I'm going to open that server up to begin listening. So I'm showing in a ready state. And now when I run my port scan script, it's going to ask me for what IP address I want to scan. So I'm just going to loop back here. And I have it set to scan all the ports around that 12345. I simply wanted to show that port 12345 was opening and listening. And you'll see a message came through that was the communication from that port scan. I'm now going to disconnect that port. So now I'm not listening anymore. And when I rerun my port scan on that same IP address, I'm now going to show that that port is closed. Okay, so two more scripts I kind of want to go through. First, the UDP. So with the UDP, instead of sending a TCP, which makes a connection, UDP makes a connection list. I'm going to be using the sock_DGRAM connection type, and basically sending a message to that port and listening in for any callback. Another script that I want to talk through is another use case for this socket connection. So in our last lesson, we talked a little bit about Yara rules, and we talked about, and when it finds a hit that, hey, you have a potential malware here, you have a potential problem, instead of just displaying on the screen to say, hey, you have a problem, what if we were to open up a socket, relay that back to a central server that's listening for these types of things, and this way a SOC analyst who may have a dashboard up with all these different sockets coming in can be alerted when a match of a possible infected file comes in. Building off the network programming we just discussed with sockets, Scapy is a packet manipulation library. Not only can it capture and read packets, it could also scan, test, and attack. Scapy can be used for wireless testing, invalid framing, and injection attacks, making it a powerful tool in the security professional's belt. Scapy can be downloaded and ran as a standalone tool, but we will talk through how to implement it in part of your Python code. Tons of documentation on the subject. The Python community has really built up this tool and supplied it with a quality documentation to learn from. As I mentioned, the primary use of Scapy is to dig into network packets, sniffing them, creating them, you name it. Scapy brings a lot of the functionality of tools like Wireshark into the code and allows you to build custom tools for yourself or your org to help in the fight. Scapy is a large third-party package and needs to be pip installed to work. Looking at the functions, although not impactful on the Python coding itself, the conf function provides you insight into the configuration and setting of Scapy. The parameters of this function allow you to make changes on the fly. SR and SR1 are part of the send-receive module and send packets at layer 3. The 1 in the SR1 is because only the first response packet is returned, whereas all answered packets are returned with the SR. The send function sends layer 3 packets with the parameters you set, which is a huge win. The parameters shown here inside the parentheses are just meant to represent that you control the details of the packet, the IP, UDP versus TCP, and over which port. Are there any flags set? And the DNS query, meaning you can send a packet to a DNS server of your choice along with the DNS QR asking for the DNS information for the specific domain. The sniff sits on the other end of this and monitors all the packets that pass by your various network interfaces, or if specified, an exact interface. The parameters allow you to set what protocol to watch for. Is there a specific IP that you are interested in monitoring, or what traffic is coming in through the specific interface? The show extends sniff and allows you to pick up one of the packets you sniffed and dig deeper into it to see all the various packet details. The demo for Scapy will cover a couple different topics. First, we'll sniff a few incoming packets and display the full detail of one of those said packets. We will then sniff some packets with the process function built in so we can take action on the packets being sniffed. Finally, packet creation. Not only do we want to use this powerful tool for listening, but when we run our port scanner and find an open port during a pen test, we can use Scapy to probe that port more and send it things like malformed packets to see how it handles it. Scapy does need to be pulled down with a pip install to begin, and I'm going to pull all the material into my script available in the scapy.all package. Looking at this first demo, I am basically saying I want to pull in and drop the next 5 packets sent to me on the screen. The end summary function will display the summary detail of those packets captured, and show function with the 0 index will show me the full detail of the first packet captured. On the server I am running this on, I will require some type of PCAP software installed to capture packets. I went ahead and installed Wireshark, which comes with the npcap and is a commercial use application for this type of operation. Once this demo is complete, I want to compare the results and show you how Scapy brings the power of Wireshark into the Python language. So let me jump into the server and start this script. And while I run this demo, I will be sending over some ping requests in the background from my laptop just to get this moving along. Okay, it has now completed the 5 captures, and you see the first packet's details being displayed. You can see the layers of the packet, the network, the IP, the ICMP, and the raw data. Over here on the Wireshark, a commercial packet capturing tool, you can hopefully find the same packet. You can see here is the data, the ICMP checksum matches, and the source and the destination IP addresses as well. Now, to take this a step further, in the next demo, we're going to take the detail of the packets captured and drop it into a function to process them on the fly. In this demo, we will print out the packet ID, the packet source, and the destination. With the Scapy2 script running, I'm going to run a few pings, and I can see the last few are also captured in Wireshark. Comparing them, I see the IP layer ID along with the IP address of the servers. The last demo for Scapy is going to flip this work, and instead of seeing the detail of captured packets, I'm going to set the detail of the packet being sent. When you find an open port on a network during a pen test, you want to poke it a little and see what it is waiting for and what kind of traffic does it handle. Looking at the code for the third demo, the send command allows me to form a packet with each layer separated by a slash. I give it an IP, then the TCP layer, and I tell it to use port 80 and flag S. Finally, the message payload. I can also create a packet with the SR1 method, as you see here, and set the IP and packet type. So when I run this from my laptop directed at the server, I'm going to add the 172.26.135.181 IP as the argument so it drops it into the target. I'm only listening to this traffic on the server in Wireshark, but as you can see here, when I narrow down the list to the TCP port 80, I can see the packet and subsequent test message. We have talked a lot on the networking side of the house. Let's move into the web and web application pen testing and some of the available packages, modules, and functions you can take advantage of. Requests is a well-documented package that can be found on the pypi.org site. There are already a few guides available here on Pluralsight for requests as well. One of them gets into the interesting use case that we will explore on web scraping and requests. This is more or less developing your own bot to retrieve information from a website. There are a ton of proper use cases out there for this type of service, but keep in mind as we go through this that this starts to border on pen testing, and you will want to be sure you have permission of any application you reach out to before running a script against it. To get started, requests does not require you to pip install it in order to import the functionality. A few of the key functions to talk through. Now keep in mind, we're talking about web calls into the web application, but the get and post are the main methods for retrieving and sending information into a server. Your browser normally handles this behind the scenes while interacting with things like web application forms. But since we're incorporating this functionality into our Python scripts, it will be on us to manage in the code. In addition to the get and pull, all methods, including put, patch, head, delete, and options are available to you. Status code is important to track any issues and that your code is operating as expected along the way. As we make our get and post requests, it is important to know if these were successful or not. Text and content both allow you to access the response that comes back, which is usually in the form of a source code for the page you called. Text returns the information in a nicely formatted Unicode response, whereas content is returned in bytes with all the new line characters and is harder to read but easier to work with in your tools. Finally, the last function I'll quickly talk about is the header function. Calling the response headers can expose you to all sorts of useful information. If not locked down, the header can expose what type of server you're running on along with the version. Information leakage is one of the OWASP top 10 items you want to look for with this tool. As mentioned, request mimics all the functions your standard web browser handles for you. It does require you to pip install the package in order to import the functions. And in this first demo, we're going to make a GET request call. This is a standard retrieve of the website example.com. With the data returned, your browser would normally read in things like the status code, header information, and content body to determine how to display the data. When I run this demo, you will see I pull in the same information and instead display the individual parts. Why would you care about the status code in this way, you may ask? Well, availability is part of the core security triad. What if you needed to monitor 20, 30, or even 100 web applications your company maintains? This information allows you to build a dashboard that monitors the status code every couple minutes and alerts you when the site goes down. Now going back, I can show you we also pull the content into nicely formatted Unicode. Let me comment this out. So when I run this now again, I pull back all the different source code for the same example.com web application. I also have another option of the print content, which brings it back in byte. A little bit harder to read, but all the same information. I also have a second demo to run. This one is going to look at the web application Juice Shop, which is available on the Heroku app. Juice Shop is a broken web application that's made for web application assessors to go through, test their tools, test their skills, try to find all the vulnerabilities of the application. In this case, I'm going to do some web scraping. I'm going to open up a GET request again that's going to go to the directory in the web server where these images are stored. I put a list together of a few images that I thought would be good to pull in, and if found, if I return that 200 status code, I'm going to grab that image and write it to my server. So what you're going to see when I write this is at the top here, these images are going to start to appear in the list. So any image I was able to find on the web server is now printed the picture and scraped it off the web application into my site. Beautiful Soup is a Python library used for retrieving elements from an HTML and XML documents using a parser. This allows you to scrape and extract data from a file, or to modify the file using Python code, then writing it back to a new HTML file with your modifications. Like all the other libraries we've discussed thus far, Beautiful Shop can be found on the pypy.org site with the documentation out of the maintainer's personal crummy.com site. This is a third-party package and does require you to pip install it before being able to import and take advantage of all the built-in functions. To begin, you will basically pass a Beautiful Soup constructor with the same name, 2 arguments, the code and which parser you want to parse it with. The HTML can be a local file. Some developers use this tool to read in a file they are working on, review and modify it with a Python code, then produce a new cleaned up file. Generally, when being used as an analyst tool or for some type of bot or scraping, you need to pull down the HTML from the server using a request call and parse the data that way. By default, Beautiful Soup will work with the built-in Python HTML parser that comes standard. It is recommended that you use the LXML for speed, especially if you're working off an older version of Python. The built-in HTML.parser is not very good. LXML and HTML5lib are installed with pip separately. Beautiful Soup is a rich library full of all sorts of functions broken down and specialized for specific tasks. I'm going to talk about 3 of them today, starting with the find and find all functions. The most important use of Beautiful Soup is to parse the file. Find and pull out all the elements you need. This can be standard tags. For example, retrieving all the A tags will give you the links of the sites which can be used for spidering. If I'm looking for data leakage, I can search for all the comment bracket patterns. Or, in the header, is it disclosing server information? For purposes of scraping images and data, the find and find all allows you to drill down on a page and gives your parser a starting point. Find all returns a list containing all the results, even if there are 0 or 1 of them. Find simply returns the value found. Some of the additional search capabilities include Find Parent, Find Next, and Find Previous, which allows you to move into the tags surrounding your starting point. Beautiful Soup is one of my favorite packages. It does need to be installed with the pip, which is currently set to install Beautiful Soup 4. This creates a BS4 package that I pull Beautiful Soup out of to import. The first couple lines here are pretty straightforward. I'm retrieving a website on my local web server I created that contains a catalog of coins. I'm using the request get call to handle this, and I am then sending the text into the Beautiful Soup's constructor and parsing the documents with the LXML parser. This will give me my tree of Python objects I can then play with. Looking at the website in question, you see I have a catalog of coins that provides pictures, names, and prices. If I'm a collector, this may be a good information I could use to help find the best value for my collection. In the source code, I can see the individual coins are separated by div tags, which has the class product assigned to it. Knowing this, I can break this tree down by individual products and retrieve the information from inside each of the div tags. I'm using the built-in find all function to pull out the individual products, but another way around this is to reference back to the regex section and build a pattern and search for that inside the code. Because class is registered inside the Beautiful Soup, I have to add an underscore to the end of it in order to use it. Once I have my list of all the div groups that contain the coin information, I can import them one by one and split them. Looking at the source code again, I see there's a line break at the end of each line that separates the money from the description and the description from the picture. Using my knowledge on strings and list parsing, I am going to grab the directory and name of each picture, retrieve the image, then call out the image, product, and amount in the results. Normally I would drop this into a database at this point, but once finished, I should see all my images in the file directory and the details in the results. As you can see here, I have all the detail from all the coins, and on the left here, I have all the images. Developers use this package to help make wide-scale changes across their web application. It is a lot easier to parse content through automated means instead of having to update content manually. With the way we develop applications changing, this will slowly become less and less important. But for now, you will have this tool available to you for your various needs, however you see fit. Wrapping up this course, we looked at close to a dozen modules and packages that really help make your job in InfoSec easier. The basics in sys, OS, and PSUtil get you into the processes and operating system. They contain functions to retrieve metrics, run jobs, and automate a ton of the quick and dirty work needed in things like incident response. Or regex is a search pattern package. You will have your hands dirty in files, logs, and other data-heavy documents. Being able to pull the information out quickly is a huge benefit. Cryptography is where we start to get into the heavier security functions, where we are able to hash, encode, and encrypt, along with cracking into the X509 certificates, securing files, and hiding sensitive data. Yara was purposely built to make your life easier. The rules can be imported and ran to help find and fight phishing, help with incident response, determine if you've been exposed to the latest zero-day compromise. Sockets and Scapy focus on networking side, while Request and Beautiful Shop focus on the web. All four provide you the help to build a bulk of the tools you will use in this industry. Well, that's it for this course. Attached to the exercise files are additional lists that contain dozens and dozens of other packages that complement these libraries. The best advice I can give you is to do your research. Understand all the nuances of the functions provided in play. The more you code, the better you will understand, and the better you understand, the more ways of implementing you can come up with, and the better results you will see. That is all for now. Thank you for watching, and keep an eye out for more Python and security courses that will expand on the detail of some of these packages in the near future.